So what do you do if you get a binomial that won't factor? So you've done greatest common factor, you factored by grouping, and you're left with something that you can't factor. Um, so what you can do is let's start with x cubed minus 27. Oh, that's a difference of cubes. So we remember that a would be x and b would be 3, and so we have x minus 3 times x squared plus 3x plus 9. If you don't remember that, go to the difference of cubes video and re-watch. So if you can notice, this can't factor. There's nothing that multiplies to give you 9 and adds to give you 3. So we have to use the quadratic formula or complete the square. So first, let's use the quadratic formula. Recall that it's opposite b plus or minus b squared minus 4ac and all of that under 2a. Well, not 2z, 2a. And let me kind of put my symbols in here. So we've got the square root of all this, and this is plus or minus, and that's a fraction bar. So that's the quadratic formula. So now we need to write down what a, b, and c equal. A is 1, b is 3, and c is 9. And we just substitute these values in for our equation, and so we should get opposite b plus or minus b squared minus 4 times a times c, all of that over 2 times a. And again, let me put my markings in here. So we're going to have the square root of this and plus or minus here and a fraction bar there. And so when we simplify, 3 squared is 9, 4 times 1 times 9 is 36, and so we get opposite b, which is negative 3, plus or minus the square root of 9 minus 36 is negative 27, and then of course 2 times 1 is 2. Again, let me put my markings in here, and in Algebra 1, you may have stopped here because this is no real solution because you can't have a negative inside of a radical. But what we learned last chapter is that we can simplify this. And the square root of 27 can be broken into three things. The square root of negative 1, the square root of 3 times the square root of 9. Cool thing is negative 1 equals I squared, and the square root of I squared is I, and the square root of 9 is 3. And so our final answer, or getting closer to a final answer, is negative 3 plus or minus 3I square root of 3, all of that over 2. Let's add my markings here. Negative 3 plus or minus 3I square root of 3, all of that over 2. Now remember, you will typically see it split up, and so an answer that will be helpful for us would be to see 1.5 plus or minus 3I square root of 3 over 2. 1.5, negative 1.5, sorry, plus or minus 3I square root of 3, and just this part is over 2. Or we could do 1.5I square root of 3. Either way, I'm going to express it like this because this will help us compare answers. So if quadratic formula isn't your cup of tea, you could complete the square. So when we complete the square, we're going to take this number, divide it by 2. And so 3 halves squared is what needs to go here. Well, 3 halves squared is 9 fourths, and 9 does not equal 9 fourths, so we need to get rid of this 9 to make room for 9 over 4. So let's do that by subtracting 9 from each side. Minus 9, and remember when we're solving, we're setting equal to 0, so we're minus 9, and so let me rewrite this. We now have x squared plus 3x plus blank equals negative 9. Now I'm going to take 3 halves squared, which I said is 3 squared is 9, and 2 squared is 4, so we're going to go 9 over 4. And what I add to one side, I have to make sure I add to the other side, because that's the rules. And so negative 9 plus 9/4. Well, negative 9 over 1, we got to get a common denominator here. So we're going to times this by 4. Multiply this by 4, sorry. And so we end up getting negative 36 over 4 plus 9 over 4. And so negative 36 over 4 plus 9 over 4, that's going to give me negative 27 over 4. And that is super helpful. So let me scroll down a little bit and rewrite this. And then the reason that we do this part right here is because now we can make the perfect square trinomial x plus 3 halves. And so I'm going to rewrite it like that. X plus 3 halves, because that's what half of our b value is, squared equals 27. I thought it was going to let me drag it, but it's not. Equals negative 27 over 4. And so now to solve, we take the square root of each side. Whoop, whoop. And so now that's going to become x plus 3 halves equals square root of negative 27 over square root of 4. But we just found out that the square root of negative 27 is 3i square root of 3. So we know that it's going to equal 3i root 3, all of that over 2, because the square root of negative 27 is 3i square root of 3. And remember, when you take the square root, you're going to get a plus or minus. Square root of negative 27 is 3i square root of 3, and the square root of 4 is 2. And so now we're going to subtract 3 halves. Oh, and what's 3 halves as a decimal? I believe it is 1.5. So x equals negative 1.5 plus or minus 3i root 3 over 2. My goodness, wouldn't you know it, we got the exact same answer as when we did quadratic formula. Whoop, whoop. There we go. So our answers, our zeros here, are going to be x minus 3 equals 0, and so x equals 3. Because if we set x minus 3 equals 0 and solve, we get x equals 3. And we have these formulas right here. So I'm just going to copy that and come up here and paste that. Oh, it only did the circle. That's hilarious. I want the inside stuff. Yeah, that stuff. And paste it. And so x equals negative 1.5 plus or minus 3i square root of 3 over 2. And there are your zeros. Yay! That'll be all. If you have any questions, let me know.